Welcome again, Wildcats. All right, so today we're looking at Tuesday, March 21st, and we're going to be solving exponentials by graphing and same base. And that's going to be on page 64. Now, on a note here, there's not going to be a video for Thursday because I'm just going to tell you now that the test 9 retest will be on Thursday, March 23rd. Now, I will be available for tutoring on Monday and Tuesday morning, and then Miss Newman is available for tutoring on Monday and Tuesday afternoon. So if you want to go over anything or review for that, we are there to provide help for you. Okay? All right. So if you would, finish up your table of contents. All right, now your table of contents is updated. Let's take a look at our notes. All right, so we're looking at solving exponentials by graphing and same base. Okay, so there's three ways to solve exponentials, okay? So the first way is to get same bases, okay? So what you're going to do in step one to get the same bases is rewrite each, or not to get the same. Once you get the same bases, rewrite each side with the same base, okay? Step two, since the bases are the same, the exponents are equal, okay? And so in step three, you're going to solve the equation, and I'll explain that next. But if you want, pause the video and go and write down step one and step two. All right, let's look at step three. All right, step three, solve the equation for x. That should say for x. Okay, so when you get to this point, you're going to have basically three paths to go. If it's linear, your step four will be to set the variables on one side equal to a number on the other side, okay? Now, if it's quadratic, step four will be to make the equation or set the equation in standard form equal to 0. Then, step five will be factor or use the quadratic formula. And then step six would be to set each factor equal to 0. Now, the third path is if you have four terms, you're going to factor by grouping for step four, and then step five, you'll set each factor equal to 0. Okay, so if you would, pause the video and finish up step three. All right, so that's the first way. The second way is by graphing. Okay, so the first step in graphing is graph the left side. Step two will be to graph the right side. And step three will be to find the intersection. Okay, so if you would, pause the video and go and write down everything for way two. All right, now the third way is with logarithms, which we're going to teach those at a later date. So don't worry about logarithms yet, just know that that's the third way, and that we'll explain that when we get into logarithms. All right, so if you would, finish up your notes. All right, now this is going to be on, your examples on page 64. Now, what I noticed about, as I was going over and thinking about how I was going to teach it, that really the assignment's kind of flipped, okay? And I was going to make copies, but then I thought, you know what, I love trees and I don't want to waste any paper. So we're just going to, I just want you to understand that basically, when you see this assignment, we're going to flip here, and we're actually going to look at example 5 and 8 first, okay? So we really need to see these first, then we'll talk about the graphing, okay? All right, and about the graphing, I'm actually going to explain example 5 and 8, okay? And I'm going to have you try 6 and 7 on your own before class. But what I'm going to leave for class is example 1 through 4. I thought about it, and I could explain some of this in the video, but the moment I started explaining it, I really had this thought that there's going to be a lot of questions. So I don't want you to watch the video while I'm explaining one and, many of that question be able. So I feel more comfortable explaining example 1, 2, and 3, 4 in class. So when that question, because there's going to be questions about it, you'll be in class with me and I can answer those questions right there, okay? So we'll address examples 1 through 4 in class, okay? All right. And again, the order is kind of all jumbled today, but again, we're going to save some trees and just go with it, okay? And that I think we should talk about example 8 first, then example 5, okay? Now, looking at the ways, we see that this is going to be solving algebraically the same basis, okay? So way 1. We notice in example 8 that we have the same basis, okay? So in step 1, we're going to rewrite each side of the same base. Well, we can skip step 1 because they have the same base, okay? So we're going to go to step 2. Since the bases are the same, the exponents are equal. So since the bases are the same, we can say that the exponents are equal. So we have x cubed plus 4x squared equals 9x plus 36. Now, I'm hoping you accept that they're equal, but in class, I want you to tell me why, if the bases are the same, are the exponents equal? So answer that question and go ahead and write, I guess you could write it right there. So explain, in a short explanation, why, when the bases are the same, are the exponents equal? And then remind me to talk about that in class, okay? All right. So here we see that we have 4 terms, okay? So what we need to do is actually we always want to move everything to one side. So we're going to subtract the 9x and the 36. So we get x cubed plus 4x squared minus 9x minus 36 equals 0. You always, when solving, you want everything on, whoa, that was weird. The video paused. What was that? It was aliens. Aliens paused the video. All right. So we have everything set equal to 0, and we notice that we have 4 terms. Okay, 4 terms. Since we have 4 terms, we know we're in the far right of our steps. So we're right here. Okay. So we're here if we have 4 terms. So step 4 is going to be factor by grouping, and then we're going to set each factor equal to 0. Okay, so we're going to factor by grouping. So here we see that we can factor in x squared. Okay, so that's x squared times x plus 4. Okay, and here we can factor out a negative 9 from both terms. So that's minus 9 times x plus 4 equal to 0. Now, because this x squared is being multiplied by x4 and negative 9 is being multiplied by x4, we can combine the x squared and minus 9 and have x squared minus 9 times x plus 4 equal to 0. All right, now we're into step 5. We're going to set each factor equal to 0. Okay, so x squared minus 9 equal to 0. Well, we add 9 to both sides. We get x squared equals 9. We take the square root of both sides. Remember, it's plus or minus the square root of both sides. So then you get x equals 3 and x equals negative 3. Okay? Now we need to set x plus 4 equal to 0. So subtract 4 from both sides, x equals negative 4. And we know we're done because the highest exponent is 3, so we have 3 terms. So there it is. There's your solution. So go ahead and finish up example 8. All right. Now that example 8 is finished up, let's look at example 5. All right. Now, we need to rewrite each side with the same base, okay? So when you see this, you have to kind of look at what the common number is. And so you have to think about, well, what number raised to what power can be the same? And so I see 9 and 27. When I see 9 and 27, I think 3, okay? So I know that 9 can be written as 3 squared, okay? And that's going to be times 8 minus x equals, now we know that, again, think about the same base. So if we're going to have the same base, we have to have 3. So 3 raised to the third power is 27. And and that's times x minus 3. Okay? So we have the same bases. Now we know that the exponents are equal to each other, so we're going to set this equal to each other. And I'm actually going to multiply and equal at the same time. So I'm going to distribute the 2 and 3 and then set equal to each other. So 2 times 8 minus x is 16 minus 2x equals 3x minus 9. Now, looking at our pathways, we can see that it's linear. So step 4 will be for the variables on one side and the numbers on the other side. So I'm going to add 2x to both sides, and then I'm going to add 9 to both sides. So when I do that, I add 2x, I get 5x. If I add 9 to both sides, I get 25. So then divide both sides by 5, x equals 5. And our highest power of exponents is 1, so we know we have one solution, so we know we're done. All right, now at this point, what I want you to do is try example 6 on your own. So pause the video and try example 6. All right, so I'm assuming at this point you've tried example 6, so now let's see if you did the work correctly. All right, so example 6. All right, so same bases. Well, I see 2 seems like a good base to have the same of, so let's think about what we can do to make 8. Well, we know that 2 to the third power is 8. So that's 2 to the third times x equals 2 to the x plus 6. Well, we have the same basis, so we know our exponents are equal to each other, so 3x equals, I'm going to go and put a 1x plus 6. Well, we know we're at the linear path, so we need the variables on one side, numbers on the other, so we're going to subtract 1x from both sides, so you get 2x equals 6, divide both sides by 2, x equals 3. Now, example 7, if you think you can figure it out, try to figure it out. If not, I'm explaining example 7 in class, okay? All right, so with that, now, I'm more than willing to go over example 5, 6, or 8 again in class, okay? But what I want you to understand is I'm not going to go over any of these in the video because I want to go over them in class and so that you can ask questions as I'm going over them, okay? So with that, I'm going to go try to save the Alamo. I suggest maybe y'all go watch the Alamo movie. It's a great movie. I think there's a movie about the Alamo. I don't know. If not, as always, have a wonderful Wildcat day.